Hello everyone. In this video, we're going to be talking about dual numbers. If you remember recently, Black Pen, Red Pen made a video and then I made a video response. I haven't heard from him yet, but let's see how that goes. And then we basically talked about an equation that doesn't have a solution using dual numbers, which is made up of epsilon. We can prove that there are no solutions, obviously. So dual numbers are very important actually. They're not just invented for fun, but they're very fundamental in automatic differentiation, screw theory, whatever that means, you can look it up, and robotics. Now, automatic differentiation is something that we're going to focus on today in this video. So I'm planning to make a series of videos on dual numbers. I know somebody suggested that I do make a separate channel, which sounds like a good idea, but given that aplusbi only attracts a certain number of viewers, it's going to be really hard for me to manage yet another channel because I have SyberMath, this one, the Shorts channel, as well as aplusbi that already keeps me pretty busy. That's why I kind of changed the schedule, so I'm not posting every day. Hopefully you like that schedule. Let me know what you think. So we're going to talk about these things, and today in this video, my focus is going to be kind of defining them one more time, giving you an introduction, and then talk about how they're used for automatic differentiation and how cool they can be. Okay, so let's go ahead and start with the definition. Basically, a plus b epsilon, as you know, epsilon is a Greek letter, which is also used in limits, and there's actually a really nice connection if you think about it. A and b are real numbers, so it's kind of like made up of two parts, like a complex number. By the way, if you like complex numbers or if you want to like complex numbers, go ahead and check out aplusbi, my channel that focuses on purely complex numbers. I'm not talking about pure imaginary, but mainly complex numbers. So a and b are real numbers, just like a complex number a plus bi. I squared is -1. In this case, we define epsilon as a number whose square equals 0. But it itself is not 0. Why? Because epsilon is kind of like an infinitesimal, super duper small. So it's positive though, but it's super small. When you square it, it's going to get unbelievably small, which we call 0 in this case. Okay? So that's the quick explanation. And these are some examples. Of course, you can provide more examples. 2 plus 3 epsilon, -5,000 epsilon, which means in this case, the real part of our number is 0. And that's something we are also going to talk about, not today, but in the next video. Okay, great. So let me go ahead and remind you one more time how we use Taylor's theorem or Taylor series. It looks like this. F of x plus h equals f of x plus h times f prime plus h squared divided by 2 factorial times f double prime, which is the second derivative, and then we get h cubed divided by 3 factorial, f triple prime, so on and so forth. You get the idea. So this allows you to write a function as an infinite polynomial. Okay, of course, as kind of like a linear combination of its derivatives, right? And there is a very easy way to prove this. You can just assume that the function can be written as an infinite polynomial and then keep differentiating it, so on and so forth. But in this equation or identity, something is super duper important. We're going to replace h with epsilon, our infamous or famous number epsilon. When you do that, a bunch of things happen. First of all, x is unchanged, but h becomes epsilon. So I'm going to replace all the epsilons with, or all the h's with epsilon. And then this is going to be epsilon squared divided by 2 factorial times f double prime, and then epsilon cubed divided by 3 factorial multiplied by f triple prime, so on and so forth. Obviously, you can replace x with a and get f of a plus h. Doesn't matter, same idea. But I want to go with f of x plus epsilon because I want to show you a general formula for what we're about to look at, okay? So notice what I said about the definition, right? We said that, okay, epsilon does not equal 0, but epsilon squared equals 0, which means all the powers of epsilon, starting with the second power, epsilon cubed, epsilon to the fourth, they're all going to be 0. Why? Because they contain epsilon squared. Epsilon cubed can be written as epsilon squared times epsilon. Epsilon is not 0, but epsilon squared is 0, so 0 times epsilon obviously is epsilon. Okay? So all of these are going to cancel out, and we're going to end up with something super duper simple. That's why this identity is very important. So I'm going to write it in a simpler form. And obviously, when you're writing a dual number, you do want to write the real part and the dual part, or if you want to call that infinitesimal part, like this. So you always want to write it in the form of a plus b epsilon. Does that make sense? Now, this is going to be a super duper important formula, so let's go ahead and frame it and save it for future use. Okay, great. Now, how do we use this formula, right? Let me give you some examples. Example number one. I usually use EX for examples, and my students are usually used to it. So after a few classes, you know. So anyways, let's just start with f of x equals x squared, right? So in this example, what I'm going to do is, so it's just a quadratic function, right? I'm going to replace x with x plus epsilon so that we can see what is going on, okay? So let's replace x with x plus epsilon. And of course, on the right-hand side, we're going to end up with x plus epsilon squared. By definition, right? By definition of the function, we get that. Now, let's go ahead and expand it. We can definitely write this as x squared plus 2x epsilon plus epsilon squared. You know the formula for a plus b quantity squared, right? But wait a minute. Didn't you say epsilon squared is 0? Yes, I did. So this cancels out, leaving us with something simple again. But not only is this simple, but it's also amazing, because if you take a closer look, you're going to realize what I'm talking about. Let me go ahead and change the colors here a little bit. Oops. So that you can see what I'm talking about. Now, we do see that f of x plus epsilon is made up of two parts. One of them is x squared, which is the original function. So this is f of x. And the second part, the infinitesimal part, is the derivative of f of x, which is f prime. What's the derivative of x squared? 2x, right? Exactly. So this gives you the function and its derivative in a single equation. That's why this is used especially by computer engineers for automatic differentiation, because who would want to go with the limit as h approaches 0, blah, 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 right? That's too hard. At least for computer people, that's going to be complicated because they do need something very, very concrete. Okay, you might be saying like, okay, x squared was an easy function. How about you use something like the square root of x? This is going to be interesting. Let's give it a try. So now we're going to replace x with x plus epsilon, and we're going to get the square root of x plus epsilon. Wink, wink, wink. We're stuck. What are we going to do? Okay, so now at this point, you have to use your super powers, especially radical powers. How do you find the square root of a dual number? Well, we are living in the dual number world, so the square root of a dual number is also supposed to be another dual number. So let's call that a plus b epsilon, okay? And then guess what we're going to do? We're going to square both sides. But when you do square both sides, I want you to write this first, because we want to find the values of a and b from here, because our goal is to find the square root of x plus epsilon, right? So let's go ahead and square the right-hand side. A squared plus 2ab epsilon. You've done this before, so you know the drill. And then b squared epsilon squared. And the right-hand side is just going to be x plus epsilon. If, oopsies, we forgot to define it, but just like complex numbers, if two dual numbers are equal, like a plus b epsilon and c plus d epsilon, of course, the real parts have to be equal, and the infinitesimal parts or dual parts also have to be equal. Why? Because it has to be. I don't know. Intuition. Okay, great. Now, what do you do with that? So here's what you're going to do. You're going to compare the real parts and I was about to say imaginary, but the dual parts. Okay, dual is probably easier to say than infinitesimal. Infinitesimal, by the way, means infinitely small, like super duper tiny. Okay, now notice that epsilon squared is 0, so we don't care about that. And now if you compare real part to real part, you get a squared equals x and 2ab equals 1, because the epsilon is just 1 epsilon. Now, from here, you get two solutions, but let's focus on the positive root. You can also do the negative root, which is very similar. And from here, b becomes 1 over 2a. So you can basically write it as 1 over 2 root x. So we know the a and b values in terms of x. And remember, we were trying to find the square root of this number. And the answer is going to be in terms of a and b, which is square root of x plus 1 over 2 times the square root of x times epsilon. I don't know about you, but this is very exciting. Why? Because if you look at this very carefully, square root of x is the original function. What is 1 over 2 square root of x? It is the derivative of square root of x, in case you didn't know. So, again, this gives us the function and its derivative. Isn't that crazy? I think so. Anyways, now let's go ahead and take a look at yet another example. I know this has been a long video, but who cares, right? As long as we cover good stuff, let me know what you think. Our third example, and this is going to be the last one, is going to be 1 over x. And from here, obviously, my goal is to find f of x plus epsilon, right? Of course, we're going to do the same thing. Replace x with x plus epsilon. This part is fairly easy, don't you think? Now, our goal is to kind of turn it into something like this, right? F with f prime. It's supposed to show up, right? But let's go ahead and find out. How do you simplify something like this? In other words, what's the multiplicative inverse of 1 over x plus, what's the multiplicative inverse of x plus epsilon? Let's find out. So we're going to multiply by the conjugate, and the conjugate in this case is going to be x minus epsilon. So we're going to use difference of 2 squares. 1 times that is the same thing. And the denominator, with the complex numbers, you know it turns into a squared plus b squared, which is sum of squares. But here we're going to have a difference of 2 squares, which is x squared minus epsilon squared. Uh-oh, our good old friend came up again. What is epsilon squared? If you can answer that question, you understand dual numbers. Are you ready? It is 0. Yay. So now f of x plus epsilon becomes x minus epsilon divided by x squared. And you're like, so what, right? I know what you're thinking. I'm going to go ahead and split it up into x over x squared minus 1 over x squared times epsilon. And if you simplify x over x squared, f of x plus epsilon is going to give you 1 over x minus, can I write it as plus minus 1 over x squared times epsilon. And what does this tell you? Again, the function 1 over x and its derivative, negative 1 over x squared. Again, if you forget the derivative formulas, you can do this. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. By the way, we're going to continue this series. Let me know what you think. If you like these videos, give me a thumbs up. And also comment. And I'll see you next time. Until then, take care and bye-bye.